Okay, we're going to take a look at discrete probability distributions and what these things may be. We'll start off with an example. So consider that I give out pocket money to my daughter according to the roll of a die. So if she rolls a dice, if she gets 1, she gets $1. If she rolls a 2, she gets $2. And so on. If she gets a 6, she gets $6. Then I start to define a few things. I'm going to define the variable M. M is the amount of pocket money that she receives, usually given a capital letter. So M is what we call a discrete random variable. It's discrete because it can only take particular values, in this case 1, 2, 3, 4, 5 or 6. It's random because the value of it depends upon a probability experiment. And it's a variable because it will change from week to week. So the variable can take one of a particular set of values, of course, 1, 2, 3, 4, 5 or 6, and there's a probability associated with each value. And because this dice is fair, it's always going to be 1/6 in this case. So M is my discrete random variable. With each variable then, we associate a probability distribution. In this case, for each value of M, so little m is used to assign particular values that the variable, the capital one, can take. So small m is 1, 2, 3, 4, 5, 6, and the probability of my variable equaling that particular value is 1/6 throughout. So this is what I call a probability distribution. Notice that the sum of the probabilities has to equal 1, of course, and the probabilities are also greater than 0. I should also add, in fact, that whilst they're greater than 0, they also have to be less than or equal to 1. So I should have an extra constraint on there. If we take an example, then in this situation I've got a missing parameter here, and the first question is to find the value of k. Well, I can exploit the property that they have to add up to 1. All of these probabilities add up to 1, so I've got 1, 3, 6, 10. So for the first one, I know that 15k must be 1, therefore k is 1/15. No problems. That enables me then to answer part 2. Probability of x being less than or equal to 3 is this, this, or this. So I've got 6 lots of k. Probability of x less or equal to 3 is 6 lots of 1/15, which, cancel that down, is going to be 2/5. And for part 3, bigger than 4, notice the strict inequality here. Bigger than 4 does not include 4, so it's only going to be 5. So x bigger than 4 is going to be 5k. So 5 lots of 1/15 is equal to 1/3. Done. Another quick example. Sometimes the distributions are given as a formula. So in this case, my variable is x. The probability of x taking any particular value is given by this formula here. It doesn't take long for me to set up a table. X can be 1, 2, 3, or 4. And the probability of x equaling x, in this case, I just substitute the number into the formula. So if x is 1, then that becomes 2 out of 34. If x is 2, that becomes 10 out of 34. 3 becomes 5 out of 34. If 3, it's 10 out of 34. And for 4, it's 17 out of 34. And I'm just going to take a moment to double check that that all adds up to 1, 2, 7, 17, 17 is 34. So yes, it does. Are they all greater than 0? Yes, they are. Are they less than 1? Yes, they are. So this is my distribution for this discrete random variable.